Notice these two words that repeat over and over, recognize and recall. Those two words are the things that the MCAT demands you do on Skill 1 questions. Recognize science, recall it, and then of course apply it to answer questions. As you can see, these three levels are: first, when a science topic is explicitly mentioned or called out in a question; second, when you get a specific example of the science, even when the topic itself is not mentioned by name; and then third, when the question is getting a little tricky on you and actually mentions a different science topic than the one that at its core the question's actually testing. And we're going to see examples of all three of these as we move through the lesson. One thing you're going to see and start mastering in this lesson is the MCAT strategy for science questions. What this is it is a method on how to attack science questions. It is flexible enough to apply to any question on the science section, but still specific enough that you know what to do next. That method is assessing a question stem, planning how you're going to answer it, executing that plan, and then answering the question, bringing it all the way to picking an answer choice. Now, this method may actually be brand new to you. You may have never seen it before, and if it is, don't worry. You're actually going to have lessons just like this one that walk through all four of these steps and different types of questions, and so you're going to get a chance to master each step on its own. But the important detail here is the text below each of the step names. What that text is how the method applies to Skill 1 questions like the ones you're about to see. The way it applies is that when you assess, you look for clues to the science topic in the question stem. When you plan, you need to recall what you know about that topic. When you execute, you're going to apply that and figure out the correct answer. And then in the fourth step, you need to find the right answer in the answer choices. Roughly speaking, for each question that we see in this lesson, we'll first see the question without answer choices, and we'll do the first two steps, assess and plan. Then we'll bring in the answer choices and give you a chance to do the execute and answer steps. We'll be seeing these Skill 1 questions in the context of science topics that you're probably already pretty familiar with. They're all from the Chem Phys, or Chemical and Physical Foundations of Biological Systems, section of the exam. These are namely stoichiometry, organic chemistry, just the very beginning of it, nomenclature, thermodynamics from physics, and fluids. Again, we won't be learning this science in this lesson. The right place to learn the science in the first place is in your books and in your videos that focus on those science topics. But the questions that we see will demand that we apply knowledge from these domains. And you'll see exactly what we mean by that in just a moment. We're going to start with the first of those three learning goals that we saw just a moment ago. That is how to answer questions when they mention the scientific principle right there. And we're going to see 4 questions that do that in just a moment. But first, we're going to see what we mean by these two verbs, recognize and recall. And what we mean by recognizing, recalling a principle is that when a word gets thrown out there, a word like entropy, for instance, you should immediately have a whole lot of things that connects to. When you hear entropy, for instance, you should think, oh, delta S, or you should think physics, you should think disorder, you should think, oh, it's that Gibbs free energy equation. When you see something like density, you should be thinking, oh, density, that's the one that's the little rho symbol, and it's mass over volume. When you see anything that hints at organic chemistry nomenclature, which is what we're going to see in a moment, you should be thinking of all of those principles that lead to that. And that is exactly what that verb means in this learning goal, to recognize the word and recall what you know about it. One of the big things the MCAT does on this section, the Chem Phys section, is, as you can see from this diagram, mixes topics. This is why the MCAT tests physics and general chemistry and organic chemistry and biochemistry, actually, although it's not on this diagram directly. That's why it tests all these science subjects in the same section, because they know there are so many shared topics. Here in the diagram, physically, it's represented by the fact that something like, well, hydrostatic pressure, that belongs solely in the world of physics, but something like entropy, well, that's between physics and general chemistry. Something like reaction analysis, well, reaction reactions are in general chemistry and in organic chemistry. And you're going to see the MCAT have a passage on reaction analysis, and you won't be able to identify whether it is a general chemistry or organic chemistry passage because they'll mix them up. But what it will be about is reaction analysis, and it'll ask you to recognize and recall principles related to that. So with that in place, let's start looking at some questions. This is our first one, and there is a word that should leap out to you in terms of science subject stuff, science topic buzzwords here in question 1's question stem, and that is heat transfer. This question says, what type of heat transfer is the primary way the sun's heat reaches the earth? When you see heat transfer, you should be having flashbacks to your physics class. Hopefully good flashbacks, but flashbacks to your physics class of that day you learned about heat transfer. And that's why there's a prompt here on the page and on your screen that says, what do you know about heat transfer? So go ahead. What do you know about heat transfer? Just jot down even as much as 5 words real quick. Now, you probably wrote something down like this. 3 different ways of heat transfer. Radiation, like the kind that we get from the sun or other electromagnetic radiation. Conduction, when one hot thing touches a cold thing and the heat moves between them. And convection, where heat moves through a fluid. And this is exactly the thought that should go through your mind before you move to the answer choices even of a question like question number 1. You see heat transfer and then bam, radiation, conduction, convection, all that good stuff pops up in your head. And if you didn't write down anything like that, then, and we'll see this is going to be a theme throughout this lesson, you can know exactly where to go to fix that knowledge. You go to your books, you go to the videos that focus on that topic, so that next time you see a question that mentions heat transfer, you know exactly what science it's referencing. Let's see a second example. This one goes into organic chemistry, and it asks us for an IUPAC name. Boy, oh boy. Those 5 letters, they must be your favorite 5 letters in the world. IUPAC, the name of that big chemistry association that names all of those organic chemistry molecules. And whenever you see a question that asks you to name a molecule, like the one that we've got here in question number 2, what needs to go through your head is a recollection of, oh, what names an organic molecule? So go ahead, write again, just 5 words or so. What's involved in naming an organic compound? There are 2 major things involved in organic compounds. One is number of carbons in the backbone. The next one is functional groups. And then, of course, there are a lot of rules, which you're probably thinking about in your head right now, as you should be. That's the whole point, about how to reorganize the parts of the name so that they end up with the exact right name for that exact right molecule. And if you're thinking about naming this molecule, don't worry. We'll get a chance to name it in just a moment. Let's see a couple more questions first, though. Question number 3 moves into the topic of fluids. And what do you know about this buzzword? We've got liquids and gases called out. What are those general properties? Now, if you are familiar with the properties of liquids and gases, then what you're going through your head is fluids. They move around. The atoms aren't locked in place like they are in solids. With liquids, they're incompressible. You can't squeeze them, but gases, you can compress them. Liquids are generally denser and also have lower entropy. All of those are facts about liquids and gases that the MCAT demands you recall quickly to answer a question like this. And again, you'll get a chance to finish this one in a moment. So if you're getting excited, don't worry. You'll get your chance to answer. Let's see one more question first, though. And this one, if you look at the question stem, it hints pretty quickly we're going to be involving a graph once we get to see the answer choices. But here, the big buzzword is hydrostatic pressure. So just with the other 3, write down in your book, what do you remember about hydrostatic pressure? Now, hydrostatic pressure is one of those with a couple different groups of knowledge involved with it. In one case, there is a conceptual aspect of hydrostatic pressure. In another case, there is a formulaic, calculation-based one. So in a conceptual way, it is the force applied by a fluid, when something's sitting in a fluid, like when you are sitting in the Earth's atmosphere, pressure on you, that's hydrostatic pressure, or when you go dive underneath the water on the deep end of the pool and you feel that pressure on your ears, that's hydrostatic pressure too. So that's how it is conceptually, but then calculation-wise, we have a formula. And the formula is that all full hydrostatic pressure is equal to absolute pressure at the surface of the fluid plus gauge pressure. And gauge pressure is rho GH, or density times gravity times height, or in other words, depth in the fluid. And this is exactly what should go through your mind. And in fact, the formula, you can jot down on your scratch paper, oh gosh, hydrostatic pressure, I bet you I'm going to have to use this formula. That's the behavior you should be doing with your hands and with your mind on test day when you see a question stem like this. And now you might be thinking to yourself, really? Some of these questions seem pretty elementary. Why are we spending a lot of time on this? And here's the answer to that. It's because, as the Kaplan tip says at the bottom of your page, if you can quickly answer these questions, if you can get the answer to the question about heat transfer in 20 seconds, super quick, you're going to have saved almost a full minute to answer questions later on in the exam, harder questions. And so any really quick skill 1 questions like these you can answer quickly is time in the bank for you to spend on harder questions later on in the section. Now, you may not be at the point in your study yet where you can really start to think about time management and sections and so on, but that's where the payoff here will come. And you're going to see, even by the end of this lesson, even by the end of the next page, that you can answer these questions really quickly, and it's going to make you feel like a rock star. So with that, let's answer these questions. So here's question number 1. Now we've got answer choices. What's the answer here? The answer is radiation. In fact, you probably heard in just the basic definition of radiation about 2 minutes ago that that's how we get energy from the sun. This is absolutely a question the MCAT could ask you, or something very similar to it. And if you just recognize the word heat transfer and recall the different types of heat transfer and what they mean, you'll get it right really quickly and you'll be done. Let's move to question number 2. This is the one where we get to name the molecule. Go ahead, name the molecule, and pick an answer. So let's talk about those principles of naming. We remember there are 2 principles: number of carbons in the backbone, any functional groups, and then, of course, rules that combine those. But the first 2 things we have to identify are these 2 things. This molecule has 4 carbons in its backbone. We can count them. 1, 2, 3, 4, and yes, there's another carbon over on the right, but there's an ester group in between, so that doesn't count as being part of the backbone. And then the functional groups, one of them is an ester group, that's this COOC, and then there's also 2 chlorine groups over on the ester. So immediately, if you remember the names that are involved here, we're going to have a BUT somewhere in there because it has 4 carbons. We're going to see an O8 at the end because of an ester. And we're going to see dichloro because that's how you name 2 chlorine groups. Well, a lot of the answer choices are pretty similar, but we can get rid of answer choices A and C pretty quickly because they don't say dichloro. But the way we can get to the final answer between B and D is to know which side of the ester the chloro is on. And if you're familiar with organic chemistry nomenclature, you might have just done this as a slam dunk. If not, then that's a really good way to identify that that's a piece of content you can go back and review. And there are a lot of resources available for you to do that in your books and your videos and your other parts of your course. But the lesson here is that the backbone is going to be on the carbonyl side of the ester. And that name is going to go as close to the end as possible. That means the whole butanoate guy is going to go near the end, and the whole dichloro, which is on the oxygen side of the ester, will go at the beginning, meaning the correct answer here is B. Again, maybe you just sat through this question and it went totally over your head. That's fine. You don't have to take the MCAT tomorrow. You can go learn how to name esters, get questions like this right on the test, and this is going to be just like any other thing you've already got in your back pocket. You recognize these patterns of the esters and the backbone and so on, and then you recall the principles and you apply them to this question. Let's move on to number 3. This one, kind of like number 1, ends up being a little bit fact-based, so it's all about recognizing and recalling those principles. We already reviewed what these basic principles of liquids and gases are, so use that and pick an answer here. The correct answer here is B. And the wording in this question is one you do have to be a little bit careful with because there's a not in there. The key here, though, is that choices A and C and D, they all are things that are true of both liquids and gases. But answer choice B is true of liquids and not true of gases. That is, liquids are incompressible, basically, and gases are compressible, making B correct. Recognizing and recalling this subject gets you a correct answer. And now let's do number 4. Told you this one was going to have a graph. Go ahead and use that formula for pressure, absolute pressure plus gauge pressure, to find an answer to this one. So it takes a little bit more work than the other questions, but still something that you can take this science knowledge that you have, it's in your brain. When you hear hydrostatic pressure, you think, oh, it's absolute pressure plus gauge pressure, and then apply it in this case to a graphical question. Now the key here, and the place where this moves from a world of science to a world of kind of algebra and the coordinate plane, is that this graph of pressure equals P naught plus rho GH looks an awful lot like Y equals mx plus B from your good old days of algebra. In this case, it's Y equals B plus mx because the absolute pressure is a constant, and then the height works as the x variable. But once you notice that, you can think about the Earth and the Moon and what you know about the atmospheres and the conditions on the surface of the Earth and the Moon and compare what those graphs are going to look like. In the first case, think about what is going to happen on the surface of the Earth versus the surface of the Moon. Which of these is going to have a higher pressure? It's going to be the Earth is going to have the higher pressure. That means either answer choice A or answer choice D has to be correct, because those are the ones that have a higher pressure at the ground level. We know the Earth has to have a higher pressure at ground level because it has a greater P naught. It has a greater pressure at the surface of whatever liquid we're talking about, because air pressure on Earth is higher than air pressure on the Moon. Then it leaves us to the slope, the second half of this equation. And because we have rho GH, H is already accounted for because we are seeing in the x-axis that the z moves from left to right, and rho is going to be the same no matter what because the density of water is the same no matter where you go. So the determinant here is going to be gravity. And which planet has the higher gravity? The Earth has higher gravity than the Earth and the Moon. So that, combined with the initial deduction about surface pressure, is going to bring us to the fact that not only will Earth start off at a higher pressure, but it will have a higher slope as you continue from zero. That matches up with answer choice A, which is the correct answer here. And that, by the way, is the really detailed way to move through this question. You might have just looked at this and said, I remember from my physics class, and maybe you even took an astronomy class at some point, pressure's always going to be higher on the Earth. There's nothing that's going to change that. And you know, maybe that's what let you pick this answer. But the point is, if you did that, then you still recalled something. You brought in knowledge from your memory in order to answer a question quickly. That's what Skill 1 questions are all about.
So now we've seen and answered 4 questions that directly call out a science topic, and we've seen how we can recognize and recall those science topics in order to answer them. Now that we've done that, let's take it one level deeper and see what happens when we have an example in a question stem rather than the name of the topic itself. Here is question number 5. It's
going to be testing a certain science topic, and you're going to have to recall that knowledge. And just as with the previous learning goal, you'll get to answer this fully in a moment. But let's look at just the question stem for now and answer these two prompts. So this question, rather than asking about general principles, gives us a specific example. But in that specific example, we have these crazy buzzwords like adiabatic and isothermal. So what science topic does that just scream out to you? What's really being tested here? It is thermodynamics, specifically thermodynamic processes. And so in the same way that you saw those questions earlier on, when we saw heat transfer and pressure and so on, you should see these words, adiabatic expansion, isothermal compression, and that should mean the same thing as if it called out and said, hey, thermodynamics, thermodynamics. Do you remember your thermodynamics processes? That's what this question is really trying to ask you. And so you'll want to recall what you know about the topic. And so just like you did a little bit earlier in the previous learning goal, write down just a few words briefly on what you know about this topic that you'll have to bring to bear to answer this question. Some things you might have written down are this big old equation. Very simple, but very important. U equals Q minus W. Change in internal energy is equal to heat minus work done by the system. You may have also jotted down the definitions of adiabatic and isothermal and what those mean. And in fact, that's going to be the specific fact within thermodynamics that we'll have to use to answer this question eventually. And you'll get a chance to do that in just a moment. Don't worry. We now move on to this next question. Again, with the previous one, it doesn't come out and say what the topic is. It doesn't read like a table of contents of a textbook or anything like that. But there are some really clear buzzwords given in the example that tell you what's being tested. Go ahead and read this and answer that first prompt. Here the topic is stoichiometry. And you probably noticed that because we have, well, a reaction, but we also have a reaction that gives us the number of grams of each reactant. That hints that it's probably numerical reactions like stoichiometry, and also that we see some unreacted chemicals, which means this is going to be a question about limiting reagents. Notice, question about limiting reagents never says limiting reagent in the question stem. That's exactly the kind of analysis and deduction that's going to bring you to really quick answers on Skill 1 questions. Now go ahead and answer the second prompt. What do you know about this on how to find limiting reagents that's going to help you answer this question? What you're probably thinking here, or something close to it, is that by definition, the limiting reagent is what gets used up first, and the other one's going to get left over. And what we're going to do to solve is, once we get a balanced equation, use the periodic table to find some molar masses and find out which one of these ends up getting left over. That's going to bring you to the answer. Another note about this question and this learning goal as a whole. When you learn more about the Kaplan method for attacking science questions, assess, plan, execute, and answer, you'll see that what we're doing here, and what we have done, what we'll continue to do in this learning goal, is really the plan step. Because what we've done is we've identified the kind of science we're going to need, and we've made a plan that will bring us to the answer. And it will bring us to the answer, as you'll see when you get a chance to answer this in just a few minutes. This will be our third and final question for this level of learning goal. And this time, go ahead and answer both prompts by yourself right now. Read it, write down what topic is being tested based on the clues that you find, and then what you know about it that you think you'll have to apply to answer the question. This one, out of the three questions, is the one that hides it the most, but as long as you can catch these words like floats and sinks, and the fact that we are dealing with an air-filled balloon in a liquid water, that we're really being asked about fluid mechanics and probably buoyancy as well. And that what we know about it is Pascal's law about pressure, the gas law about pressure and volume, and buoyancy. We're going to have to apply all of those and bring them to bear. So let's go ahead and make the final step, find the real answers to these questions to see how this method of thought, this training of recognizing and recalling, helps us answer quickly. This is question number 5 from earlier, and the table on the right is just for your own reference. Just in case you forgot a little bit about what these processes are, we'll just give them to you, because the real key here is applying the knowledge that you have. Whether that knowledge is in your head or you're getting it from the table, it'll give you the chance to answer this question. So go ahead and pick an answer now. The answer here is C, that the final state of the gas will have a lower energy than the initial state. That's because the first thing that happens is it goes through an adiabatic expansion, meaning the gas has to do work in order to expand. That takes away from the internal energy, and then it's isothermally compressed, which means that yes, it has to compress, but it's isothermal, so the temperature has to stay the same. And for our purposes and thermodynamic processes, temperature is internal energy, meaning the internal energy will stay the same during the compression. If the internal energy is going down during the expansion and staying the same during the compression, then at the end of both of those processes, it's going to be lower than it was at the very start, which is why C is correct. And now, again, there's an important distinction here between knowing this content before you answer the question and then applying content that you know. So if you got this question wrong, make sure that you identify which of those two reasons was why you got it wrong. If you got it wrong because you just had no idea what adiabatic and isothermal compression meant and how to apply these thermodynamic processes, then you need to go back to your books and your videos and so on to solidify that knowledge. But if you got this question wrong even though you knew that, then it's going to be a matter of attacking MCAT questions. And so if you know the content but you still got this wrong, then you got to go to practice questions in order to get better at answering questions like this, and think very consciously about these learning goals in this lesson, about recognizing what a question is about and then applying it to an answer. Then there was number 6. This was the one that we identified was about stoichiometry and limiting reagents. So go ahead and bring this one to a full answer. The answer here is B. And you may have had to use your periodic table that's right at the front of your book and that's also available on test day in order to answer this. But once you find out that the atomic weight of iron is much larger than the atomic weight of sulfur, and the fact that we start with equal proportions, basically, 26 is really close to 24. You start with basically equal proportions of both, and you need equal proportions of both to make your final product of iron sulfide. There's just 1 mole of each. Then whichever one has the lower atomic weight is going to have more moles involved, and that is enough to pick answer choice B as the right answer. One important note here that is a little bit to the side of what this lesson is about, but still very relevant, is that the exact number is completely irrelevant. You didn't need to do any calculation in order to answer this. And that's because every single answer choice says 8 grams. If every single answer choice has the same number, then the number is not going to be relevant in actually finding the answer. This is just one more pattern that you might see on test day that can save you a little bit of time and effort and calculation. Then there's question 7. This one's about buoyancy and pressure. Go ahead, read it all, and pick an answer. The correct answer here is A. The balloon gets compressed, which increases its density. It's a very simple statement. You compress it, increases density, and then it sinks, but it actually requires a lot of science knowledge to integrate. So if you got it right, give yourself more of a pat on the back than you might have at first thought. Because in the first place, you need to realize the balloon can be compressed because there's air in it, whereas the water can't be compressed. Then you need to know the basic definition of density, knowing that if you compress something without taking away its weight, that its density increases. And then you have to know about density and sinking and floating, and that if you increase density, you might cause something to sink when it otherwise floats. 3 discrete pieces of science knowledge which were all daisy-chained together to answer this question. And again, if you did get this wrong, make sure you know which of those 3 pieces tripped you up. That is where your study is going to have to focus. It's not always enough just to say, oh, I'll go back and read that whole chapter again. You need to know exactly what about a question made you get it wrong, and then fix that piece of missing knowledge. And before we move to the next learning goal, a fun little fact here that you may or may not have noticed, this question, question 7, actually requires the exact same science knowledge as question number 3 from earlier on in this lesson. You can go back and look at it. Both of them require your knowledge that gas compresses where water doesn't. This is a perfect example of how the MCAT can test the same science knowledge in 2 different ways. And we're going to see even a little bit more of that before the end of this lesson. So far, we have exercised our ability to use this recognizing, recalling, and applying process at a level of if the science topic gets mentioned, and then if it doesn't quite get mentioned, but there are really strong examples and hints. But now we're going to go to the deepest level, which is how to recognize these scientific principles when the question is even perhaps leading you in a different direction, making you think it's about something else. So let's see that and get a chance to practice this final, deepest application. Here's question number 8, and from an objective perspective, this is probably the hardest question so far in this lesson. We see in the question stem that it directly calls out the liquid phase. The situation is that you have a cube of solid ice and a glass of water, and the ice melts to the liquid phase, and we're asked about the level of water. So in one sense, we're directly being asked about phase changes, liquids, solids, gas, and so on. And the types of science knowledge that connect to phase changes are things like heat of fusion and Q equals ml and all of that. But because this question asks us about the level of water, and that's where the final answer comes from, what we really are going to be using to answer this question is buoyancy. So even though this question is about solids and liquids and the difference between them, to get to the final answer, the knowledge we have to apply is about what happens to floating objects versus sinking objects, and what happens when this ice cube goes from a floating solid ice cube to a liquid that is just dispersed throughout the rest of the liquid. What we're going to have to apply here is this fact. The fact that when you put an object in a liquid, it's going to displace either an equal mass of fluid if it's floating, because once it displaces an equal mass of fluid, the buoyant force and gravitational force will cancel out, or an equal volume of fluid. If it sinks, it's going to displace its volume of fluid and then sink to the bottom of the container. And the answer here, believe it or not, is answer choice C, that the level of water will actually remain the same. In order to understand why this is, consider the amount of fluid that will be displaced, first, when the ice cube is full, solid, and floating, and then second, when the ice cube has become a melted amount of water. First, when it's placed in the water, the ice cube displaces its mass in water because it floats. That's one of the principles of buoyancy. But then after it melts, the ice cube has essentially become its mass in water. So both before and after, it displaces an amount of water equivalent to its mass, and therefore the water level remains the same before and after. This question is a little bit difficult, so don't feel too bad if you got it wrong. But make sure that walking away from this question, you know exactly why choice C is correct. Because this level of application of these science principles is going to be exactly what you'll see in Skill 1 questions on test day. Question number 9, while a fairly challenging question in its own right because it's so long, also does the same kind of switcheroo that we see from question 8. Go ahead and read through this. You don't have to read through more than just the question stem for now, and answer the 3 prompts. After we see those answers, then we'll answer the question as a whole. So write down which topic is directly mentioned, which one is related and actually just as relevant, and then what you already know about that you think will help answer the question. In this case, the topic that gets called out right in the first line is acids and bases. We see that a student is mixing a strong acid and a strong base. But what we're really going to end up needing is knowledge of stoichiometry, because the student mixes sulfuric acid and sodium hydroxide, but then ends up at a different stoichiometric place than they initially might have thought. They might have thought they were going to end up in a neutral place. They end up in an acidic place. And the reason why this is because of the underlying numbers. Because what's really going to be necessary to get to the right answer is a knowledge of the normality of the situation and of limiting reagents. We'll need to make sure we have a balanced equation and then consider normality rather than just molarity. And you might be thinking to yourself, hold on, didn't we just see a question that was about limiting reagents and having something left over? Yes, we did. That's what question 6 was about. And that's not an accident, because this is yet another way that we're showing how the MCAT can test the exact same concept in more than one way. So, knowing that the knowledge to apply to answer this question is the same as what we saw earlier on in the previous learning goal with number 6, go ahead and read the answer choices and pick a final answer now. The answer here is C. If you remember from acid and base chemistry, sulfuric acid is H2SO4, where sodium hydroxide is NaOH. That means sulfuric acid is divalent, sodium hydroxide is monovalent. So if you start with an equal molarity of each, the sulfuric acid actually has twice as much normality, which means that if you have them both fight each other, the sulfuric acid is going to come up on top, and the resulting solution will be acidic because there are just more protons on the sulfuric acid than the hydroxide and the sodium hydroxide can accept. So again, even though there are a lot of words in this question and it requires a synthesis of acid-base knowledge and stoichiometry, what we really want to take away here is that even though it's really long, it ends up requiring the same knowledge and reasoning connections as the much simpler question we saw back on question 6, and that a question can be about stoichiometry without really calling it out directly. And here we are at question 10, the last question in this lesson. It directly mentions and it leads with some pretty intimidating reaction stuff. You've got this image, and if you are not really that confident in your organic chemistry skills, you might be running in the opposite direction when you see this question. But if you can just make it down to right here, where we actually see the question, it tells us that we don't have to know very much about this reaction mechanism or the details at all. All we need to know is the nomenclature for the different functional groups in compound F, which is just one part of the figure. So in order to get to a final answer, you want to apply what you know, which is on the one hand just the names of the different functional groups and also how they might work in combination to find an answer. So go ahead and apply your knowledge of that to pick one now. The answer here is D. This molecule has a phenyl group. Phenyl group means that big old benzene ring. It has an amide group, which is this one up here with the carbonyl and the nitrogen, and then also an imine group, which is a carbon double bonded to a nitrogen. As long as you can keep your name straight and look at this molecule without getting too freaked out about everything that's around it that might be a little bit scarier, this question is a lot easier than it seems. And while you may not run into a question exactly like this on test day, you might have something very similar in that you'll have a passage that presents itself as something very complicated, very difficult, something that you're not confident on, but that has a few questions like this one that are a lot easier. So if there's one lesson to take from this question, it's not only how to recognize a particular topic when it's called out, but also to look for easy questions about difficult passages and seemingly difficult content. And also, one last time, notice that this question tested the exact same knowledge way back from question number 2. There are a lot of different ways that the MCAT can ask you how to name a molecule or ask you to name a molecule in the middle of a larger question, but no matter what, it requires the same knowledge. So if you identify that that's why you get a question wrong or why you struggle on a particular practice test, then that is the chapter and the videos and the so on for you to go back and review. And that's it for this full lesson. And even though you might not be fully practiced or memorized on the strategy for attacking questions, assess, plan, execute, and answer, it's worth noting that this whole lesson was about those first two steps, assess a question and plan your attack, and specifically about the first one, that you can assess a question, see how difficult it is and what it's about by finding out what science knowledge it's going to demand. What we saw in this lesson was how those science topics can be called out either directly by saying, hey, hydrostatic pressure, here I am, or by giving an example that doesn't quite mention a word like thermochemistry, but might mention a couple thermochemistry related words like isothermal and so on. And we also saw that third deepest level on how to make sure we access the right knowledge and identify the knowledge we need when the question seems to be throwing us in a totally different direction. A question, as we saw, that ends up being about buoyancy when you think it might be about phase changes, or one that ends up being about nomenclature when you think it might be about much more complicated